And we're going to take the following steps. We should think about what happens to asymptote. We will draw asymptotes first, and also x-intercepts. Let's start with the easiest of them all. Horizontal asymptote is the easiest because it will just be a change in value. If it was initially 4, now it's going to be 1/4. Your new vertical asymptotes comes from the current x-intercepts. Your -6 and -2 becomes vertical asymptotes now. X-intercepts becomes vertical asymptotes. So you will have those values at -6 and at -2. Then let's think about the new x-intercepts. You have actually got a vertical asymptote here. The y-axis is a vertical asymptote. Vertical asymptote will become x-intercept. For x-intercepts, we mark out with a dot first to indicate later I need to pass through this point. It's just like your x-intercepts becomes vertical asymptote. It's the vice versa. Okay, so vertical asymptote now becomes x-intercept. There wasn't any y-intercept, so we don't need to touch that. If there was y-intercept, then we do reciprocal of the value. Okay, so that's step 1. We now do step 2. Step 2 is optional. The concept is the signs are preserved, which means any positive y values in your new graph, it will still be positive 1/y. Similarly, negative y values will be negative 1/y. To use this carefully on our graph, I'm going to highlight the regions that are below the x-axis first. If I know that the signs are going to be preserved, it means that this segment below the x-axis will still stay below the x-axis here. I mark out as a box to indicate that later we will draw in the yellow region onto this box. It cannot cross the axis. Those with negative y values remain negative. So the other region, same. I'm going to draw my graph later in this box. I don't know how the graph looks like yet, but I know it must fit into that box because the y values will have the same sign. Same goes for the region that are above the x-axis. These all have got a positive y value. So when we draw it, it will now be inside this box in the positive y values zone above the x-axis. They shouldn't cross the axis within each box because the signs are preserved. Okay, so as beginners to this kind of graph, you may want to draw in the boxes to guide yourself, but it's completely optional. Before I go for the last step, and last step is always to take care for each segment. Check the following. I need to know what to do with the endpoints and also turning points. Okay, so let's deal with this last part. For the yellow segment here, each segment means once it changes color, or if it's a vertical asymptote, I will stop. So we are going to check for this yellow segment at these two positions. Try to understand and mark out their new positions. Left-hand side here is a value at negative infinity. It's going down. What is 1 over infinity? It will give you a very small value close to 0. So can I mark out close to the x-axis? But it won't touch, it will just be very close. On the right, just before negative 6, it is currently 0. So 1 over 0 gives me negative infinity. 1 over 0 gives me negative infinity, just to the left of minus 6 at the same position. Once you mark out these two endpoints, we can connect the graph this way. I will not be able to connect in this manner because it will cut my asymptote. So usually the connection is straightforward. You draw it such that it goes close to the asymptote. Then we focus in the middle, this portion, endpoint, these two parts, they are very close to 0. The y value is very close to 0. So to the right of minus 6, it's now at infinity to the right of minus 6. To the left of minus 2, it's now also infinity. In the middle, there is a maximum point. Above, currently below the asymptote. So it will now be drawn above the asymptote as a minimum point. I expect it to do like this later on, but must be above the asymptote. So this point is my negative 3/2. And we get it connected. Next, yellow region to the right of minus 2, this is about 0. To the right of minus 2. So to the right of minus 2, it's now at negative infinity. Why is it not at positive infinity? It's because this is negative value. Anything that's negative value will become negative still. Towards the right, this is at negative infinity. So it will become 0, which we have a point marked out. I expect to connect up this way. The connection is always to make sure that we do tend towards the asymptote. So last segment, infinity. This infinity is at 0. We already have that point. The right-hand side is now a value about 4. And importantly, it is lying above 4. Above the horizontal asymptote. So I expect that on the new graph, it will be still close to the horizontal asymptote, but must go below. And then we can complete the graph. Join up nicely so that it goes close to your asymptotes at the end. And hence we get a 1 over fx graph. Just one last feature first on a special situation. On this left-hand side, because this graph tends to minus infinity, look at what happens to the new graph. It tends close to the horizontal axis. It creates a new asymptote at 0. Only for this special case, where the special case we are looking at is on the left and right endpoints. If you had a graph that goes to infinity, it must now go to 0. It generates a new asymptote. This is the only situation that you get a new one. Okay, so take note of this particular position that creates a new asymptote.